Can you hear me?
Yes, sir. Yes, sir.
So I just brought it because many of you mentioned in the feedback that I should get a mic. So I want to just get started with the feedback. Thank you for providing feedback. Most of you seem to be following the lectures, so that is a good sign. To follow up on and show what the changes that I'm going to make moving forward. So most of you find them to be useful, the notes that I'm up, but some of you have asked it to be in the form. So I'm going to make PPTs and upload. So then mix of both handwritten and PPT sometimes. I'll do this example class. So using Blackboard is your preferred choice for engaging in the lecture. So that's why I'm not using the camera anymore. So I would be using lectures, and I'll be using PPT and the Blackboard for explanations. So these are the changes. And I just then you and the subjects. So मेरा हिंदी इतना अच्छा नहीं है, तो किसी को हिंदी प्रॉब्लम है तो स्टडी बडी से ट्रांसलेट करवा दो लेक्चर रिकॉर्डिंग्स के हेल्प लेके, ठीक है? So some of you may be very well in the subject, so you should be open to explain to your friends. Some of you who are not so well, doing well, you should be open to seek help. So there should be both hands. You should be willing to hear and should be willing to learn. And syllabus divided into two parts. For revision, you will have unit 1 through completely and only a little bit of unit 3. For end semester, it is to be only units 3 to 5. So in the end semester, you will not see it's 1 and 2. So it's be 5. And no. So in semester, the two are not going to appear. It is going to be only 3, 4, 5. Because for units 1 and 2 already you're doing quizzes, you're also doing exam. So I don't think there is a point in repeating it again. So you should be focusing on the remaining courses. All right, so let's get started with canal irrigation. So many of you have also asked for more group activities or interactions in the class. So we'll start with that. In this unit, we are going to see different canals and the parts of canal, and also how to design a canal. So this is our first group activity. So each desk is like a group. So if you have a team, that is a group. If you don't have any teammates, please come to other benches and form a team. So each of your desk is a group. I want to look at canal system in India. And then each group, you try to find out 3 characteristics or 3 information, 3 pieces of information about that canal. So how long is that canal? and what is its purpose. So once you find the information about that canal, go to Google Classroom. You all have Google Classroom app. So if you have the app, Google Classroom app, you will find a new announcement. So it says list of canals in India. So there would be a post that says list of canals in India. So below that post, I want each group to mention those 3 points about the canal that they have chosen. And your team can have it. For example, here I have written water rangers. So water rangers is a team, and they have written some 3 pieces of information about the canal. Sorry? It's up to you. I mean, each desk, ideally each desk is a team. And it could be 2 or 3. So I want each team to write the comment so all of us can review it later on. So that we get an idea of the canals in India. So you need to pick one canal system and then write about it. Now, in the class, how many? It's up to you. There is no word limit. I just want 3 pieces of information. There is no word limit on it. Any 3. Any 3 pieces of information, the length, location, purpose, and what is the current status. Yes. In the comments. No, group, only one response per group. So you are a group, you are a team. So together you have to write one response. No, it's okay. So we got one response, team, IR canals, irrigation canals. I assume what does it mean? Okay, sir. We got one response from irrigation canals. Narmada main canal. It is a contour canal and it's the biggest lined irrigation canal, 458 kilometers long from Gujarat to Rajasthan. So in that there are two words. So one is contour canal and the other is lined canal. So those two we are going to see what is the difference between contour and a lined. थोड़ा जल्दी कीजिए, टाइम नहीं है हमारे पास. Okay, one more minute. We'll move on. Okay. So 2 minutes. Two minutes. Wait. All bench are, so ideally each bench is like a key for a group. Okay, one more minute and we will move on. Okay, so there are nine comments so far. Waterways, we have team waterways, and they have chosen Agra Canal that's opened in 1874, mainly for navigation. And later navigation was stopped in 1900s. Now it is irrigating 1.5 million acres. So it was started for irrigation, but now it is irrigating 1.5 million. And it runs through Delhi, Haryana, Uttar Pradesh, and Rajasthan. Okay, so somebody got it from ChatGPT. Certainly, here there are 3 key pieces of information. They forgot the team name. So Indira Gandhi Canal, irrigation squad. Again, Indira Gandhi Canal is India's longest canal, carries water from Satluj and Beas rivers in Punjab to Thar Desert. Water Avengers, Agra Canal starts from Okhla in Delhi, length 230 kilometers. Indira Gandhi Canal again. Sprinkler Squad, Narmada Canal inaugurated in 2008, 460 kilometers long. Team Buckingham copied from the slides. No? It's okay. And we have Aqua Engineers, Indira Gandhi Canal. Kalapani, Setu Samudram Canal. It's a shipping shortcut. Lord of the Seas, Anicut Canal. Team Godavari, Kakatiya Canal. Irrigation Group, Eastern Yamuna Canal. Deep Canals is Western Yamuna. Pesticides, Sharda Canal. Okay, so each of you have mostly picked a different canal. All of you need to see the list of canals that your other groups have posted. So you get an idea of the different canals and how long they have been running for and what is their main purpose. So we are going to see the classification of canals today. And then once we understand the classification, we will move on to see what are the parts of a canal system. And in the next lecture, we will start with the detailed survey and preliminary surveys required for designing a canal system. Now, looking at this, what are the purposes like an irrigation canal is built, or a canal is not an irrigation canal? So what are the purposes? So it could be for irrigation, hydropower, or navigation. So some of you have listed canals that are built for navigation, but now are being used for irrigation. So if it is built for irrigation, how different is it from navigation canals? So what difference would you expect between navigation and irrigation canals? So for navigation, you need deeper channels first, and because you need sufficient depth for the ships or the boats to be able to move. And then what about the flow velocity? So which can have high velocities relatively. So can irrigation canals have high velocity or navigation? Irrigation. And what about navigation? What would be the problem if it has high velocity? Yes, so it may change or it may impact the motion of the ship. And also if the ship, yes, yes. So from moving from upstream to downstream, it becomes difficult. So you need to spend more energy to overcome that. And hydroelectric canals, can they be similar to irrigation? Or can they be similar to navigation? Or can they be combined with either navigation or irrigation? What about the velocity? So we need more velocity. So you can combine irrigation with hydroelectric canals. So for example, we are drawing water from a river that goes into power generation plant. And once the water has been used, it has to come out of the turbines, right? So once the water is coming out of the turbine, that can be used for irrigation. So hydroelectric canals can be combined with irrigation, but navigation cannot be combined with irrigation because of the difference in flow velocities. I'm sorry. I just need to share the screen. I forgot those two were linked for a minute. I'm sorry about that. So what about the source of supply for the canals, rivers? So based on the source, how can we define or how can we classify the canals? So we have sources like perennial sources, and sometimes we have only sources because of inundation or flooding from the rivers. So based on the source of supply, it could be permanent canals where you have water source from a perennial river. So throughout the year, you can draw water from the river. And so you can have permanent structures in the canal. Like in the river, you can have headworks, which we will see moving forward. And those can be permanent structures. So that's why if you have perennial source, we can have permanent canals. And in some cases where we do not have water flow in the river throughout the year, and if we are only depending on the flooding in the river, then that is inundation canals. So in inundation canals, we are not going to construct any hard structures. So the canal would have an entry or opening from the river. So when the water level reaches a certain level, the water will start flowing into the canal. So we are not regulating how much water is entering into the canal. So we have perennial canals which take water from perennial rivers. What about non-perennial canals? So if you combine the first two, so in the first statement says you can have hard structures for drawing water, and then the title says non-perennial. So it means in rivers where the flow is not perennial, you still have the control structures. Yes, yeah. So you have the control structures like a weir, and once the water level is building up in the river, you draw water from the river into the canal. So you're still regulating the water flow into the canal. And inundation canals mainly depend on the flooding that happens in the rivers. So we are not constructing any regulators in the channel. So once the water level exceeds a certain level, it is automatically going to flow into the canal. So when we classified based on the purpose, it was irrigation, hydroelectricity, and then navigation. So the reason I wanted to look up for canals is you found the examples for canals which are built purposefully for navigation, which are built for irrigation, and which are built for hydroelectric power. So generally, we may not be building canals, especially for hydroelectric canals. So it would be combined with irrigation. Now, what about based on the function of the canal? So what do you understand by these terms, feeder? So what do you mean by feeding a pet? So feeding, so what does feeding mean? So I'm feeding my pet. Not to the fields, but to a different canal. So the purpose of feeder canal is only to supply water from the river into another canal. So here you are not doing any kind of irrigation. So the only purpose is to divert the water from the river into a canal system. So these are feeder canals. And what about carrier? So if my dog likes Parle-G, I can feed my dog. I can also eat Parle-G. So it is serving two purposes. So you can do irrigation in the canal, and you can also feed into a different canal system. So it is serving two purposes. What about the contours? So we have seen flooding by field channels in the irrigation systems, methods of irrigation. So what could be the direction of field channels? There are multiple possible directions, right? So one is along the contour, and the other is perpendicular to the contours, and the other is at right angles to the supply channel. So similarly for canals, there could be two types. So one, if you follow along the contour line, you build a canal, so that becomes contour canal. So you found out a canal which says contour canal. So that is built along a contour line. Now, if it is built along the ridge, so do you understand the term ridge? Ridge, R-I-D-G-E. What is this? Leaf. But so in hydrology, it is called catchment. Have you heard of catchments? Yeah. So these are the contour lines that you have. And what is the boundary of the catchment? So that is the highest points, right? So this is the ridge line that connects the highest points on the boundary of the catchment. So if your canal is going along this ridge line, so that is ridge canal. So what if the canal is moving here along a contour line? So that is a contour canal. Now, what would be the difference between these two? So let's say in a contour canal, what would be the direction in which you can draw water? So can you draw water on both sides or one side? We are talking about gravity flow in a contour. So let's say this is 100 meter and this is 95 meter and the flow is in this direction. So can the flow move here or both? Downside. So in contours, it is going to be on one side. So you can only irrigate on one side using contour canals. What about ridge canals? Both sides. So there would be one more catchment, and you can design one more canal system from this canal. From the ridge canal, you can have canals. So that's what you see in this figure. So these dark lines are the contour lines, and the canal is following more or less parallel to the contour line. So that is a contour canal. And if it is built along the highest point, then that is the ridge canal. What about the soil types? So we have seen different types of soils in one of the lecture. Alluvial soils, forest soils. So if it is constructed in an alluvial soil, what would that canal be? If the canal is in alluvial soils, alluvial soil plus canal. Alluvial canals. And what are non-alluvial canals? अच्छा, तो इन दोनों में डिफरेंस क्या होता है, alluvial और non-alluvial? Think about flow. Flow velocity कैसे impact करता है soil को? Percolation and friction. And what can happen to the channel? Soil को क्या हो सकता है? Erosion. So alluvial soils can easily get eroded. So we need to provide protection in alluvial soils. Whereas in non-alluvial soils, it may not get eroded easily. So there it may not require lining. So again, you mentioned in your write-up lining. So lining is when you provide protection for the canals. It could be concrete. So you might have seen concrete canals in pictures. So that is lining. Or it could be rock armors on the banks of the canal. So you provide rocks along the slope. So that would be another protection. So what about line canals? Because we have protection provided for the soil, we can go for high velocities in the lined canals. So what are the parts of a canal system? So we have seen a canal system in one of the lectures. Do you remember? So this is a river. So to draw water from canal, what do we require? So we require a weir or some sort of control structure in the river to control the flow. And what would this canal be? So this is main. So this is the main canal. And in the main canal, what structure? So controlling the water level in the river. And we should also have control in the canal. Here you would provide regulators to regulate how much water can enter into the canal system. So these are called headworks. So where you have a weir and then a regulator here. Now, what about the ecosystem? So if we have fish in the river that's trying to move upstream or downstream, so can it jump on top of the weir? So we need to provide some provision so the fish can also safely navigate. So for that purpose, we provide fish passage. So it may be ramping up or ramping down. And here we have some buffers. So what the buffers do is, let's say the flow is entering through the fish passage. So the flow is going to hit this wall, and so behind this wall it is going to create a shadow where there is low velocity zone. So in between these two buffers, the velocity is going to be low, and the flow is going to be diverted towards the corner. Now, if the fish is entering this passage, it can take rest between buffers in the low velocity zone, and then it can move. It can start moving upstream again. So again, it will take rest between buffers, and it will start moving. So that is the purpose we provide fish passages. So we are creating low velocity zones and low turbulence for the fish to navigate. Now, from the main canal, what would be the next canal? So it's going to be a branch. And from the branch, so you could say, so main, and from the major distributary, and from the branch again it can continue onto a different distributaries. So this main canal can continue and have different branch. Now from the minor distributary, what would be the next? So next is the field. So this is field outlet. And what happens in the field? So in the field, we have seen methods of irrigation. Of course, we have to do irrigation based on different methods. So in the branch, usually the discharge range could be up to 200 meter cube per second. In the major distributary, it can be 10 to 200. And in the minor, is less than 10. Now, have you seen any of these before? At the field. Yes. So have you seen this before? So have you seen any of these in real? Barrages, weirs? Now I just want to show an example. If you have not seen one, so there is one famous one in Parakasam barrage. So you might know Krishna River. So this is built across Krishna River. And there are two canals that take off from this barrage. So you can see there is a main river that is going on. And on both sides, you have two canals. And this is what the barrage looks like. So it has gates that can regulate the water flow from upstream to downstream. And the canal also has a regulator that can regulate the water. So it is hard to see here, but I think it is somewhere here. And this is what a fish passage might look like, where you have buffers that would create low velocity zone. And this is a sketch of the canal headworks. So we have a weir across the main river and a fish passage. And then we have the canal that is taking off from the river. And these are the guide banks that guide the flow to streamline the flow into this construction. And then these are marginal bands to provide protection from floods. This narrowing of the river, the water level is going to increase. So this would protect from inundation or overflowing. Now we will do one more group activity before we close. Shall we move on to group activity? So again, each team, I want to think about floods. So I want each team to think about floods and what could be three causes of floods and what could be three impacts of floods and one flood event which you might have experienced or which you might have seen in the news. So each team think about this, and again there would be a post in the classroom. So that says list about the flood event. So I want you to write it in the comments. So I do it now. And after the class, I want all of you to review your other colleagues' responses in the comments. Thanks. So we have three responses already. So water avengers, the causes are heavy rainfall, melting of snow and ice, and failure of water storage or water diverging structures or diverting structures, I assume. And the impacts: property damage, health risk, economic disruption. And pesticides have put biggest and oldest canal system. Oops. So irrigation squad has 3 causes and 3 floods, 3 impacts: heavy rainfall, storm surge, dam or levee failure. Again, property damage, risk to human life, environmental degradation. You forgot the remove star from ChatGPT. Robotics irrigation floods are often caused by heavy rainfall, rapid snow melt, or storm surge, or tsunami. Floods can cause widespread devastation, resulting in loss, damages, property, and critical public health. So keep those coming in, and all of you please review what your classmates have written. And so this is the last class for this week. I'm on leave on tomorrow and Friday. So the Friday's lecture, I will record it and upload it on the classroom so you can watch it. Once I upload it, I'll send a notification as well. We'll have the next class next week or next Tuesday.